Hello, I'm Hadi and I want to present our work at University of Alberta, improving LLM's attachment to external knowledge in dialogue generation tasks with entity anonymization. Knowledge graph-based dialogue generation is the task of generating responses based on a retrieved subgraph, conditioned on dialogue history. Our preliminary studies show that LLMs detach from the provided context in KGDG. As shown in the example, we are talking about our neighbor Peter Parker, while the LLM links the name with Spider-Man movie and assumes that Peter's uncle is Uncle Ben. This is likely due to their vast amount of knowledge obtained from pre-training. We call this detachment from the context, which is quite different from hallucination, because the generated response is not factually incorrect. However, it is totally irrelevant to the context. To measure the attachment, we propose LLM CAT, which is a more robust evaluation procedure to evaluate whether a response is attached to a triplet or not. The measure is inspired by knowledge verifying question answering, or KQA, where we convert the task of evaluation into Stanford question answering format. Despite the prior work, we utilize LLMs to extract the entities from the response. By doing so, we prove the risk of producing false positives will decrease. As shown in the table, LLM CAT have shown less false positives on an impossible to answer synthetic dataset. Back to detachment problem, we hypothesize that such detachment is caused by LLM's internal knowledge. So, if we cut the link between internal knowledge and context, detachment should decrease. To address this problem, we propose a simple yet effective approach. Anonymize entities in the whole context, including dialogue history and knowledge subgraph. We convert each entity name to its type followed by an identifier. For example, Peter Parker will be converted to person number 1. A prior work claimed that LLMs are advanced anonymizers. Then we utilize a strong LLM QWQ to anonymize conversations and knowledge triplets. We prompt QWQ to first provide a mapping between entities and their type, followed by their IDs. Regarding to the mapping, we convert conversation history and triplets into their anonymized form. It is worth noting that LLM will change the acronyms and other forms of an entity itself. We utilize OpenDial KG dataset, which contains dialog terms with their corresponding subgraph for next occurrence. Overall, we have 37,000 dialog generated terms. We employed QWQ32 billion to convert OpenDial KG dataset into its anonymized form. Now, we have two versions of the same dataset, normal form and anonymized form. We evaluate the performance of different LLMs with LLM CAT on the KGDG task, comparing these two versions. As for reasoning models, anonymized version of the dataset showed an improved attachment score comparing to the normal form across all DeepSeek R1 models. Same result for regular large language models. We experimented Qwen 2.5 and same anonymized version of the dataset has shown a better attachment to the subgraphs compared to the normal form. We also experimented the same pipeline with the more detailed prompt. We include more detailed instruction for language model to follow the external knowledge triplets. Consistently, the anonymized form showed a better attachment to the triplets, even with a more detailed prompt. In conclusion, we experimented 6 types of LLMs with 2 prompting styles. Across all the experiments, LLM's attachments has improved with our anonymization trick, even with strong LLMs. It is a strong sign that our approach is universal to all LLMs. Furthermore, we introduce a more reliable approach, LLM CAT, to measure whether a response follows a triplet or not. Thank you, and please do not hesitate to contact us if you have any questions.